Good day, learners. Welcome to Mathematics lesson. My name is Nonkululeko Mbuyisa. This lesson is brought to you by Sci-Bono Discovery Center in collaboration with Gauteng Department of Education. Okay, in today's lesson, we'll be looking at finance and growth. At the end of the lesson, learners should be able to solve problems with different periods of compound growth and decay, including nominal and effective interest rate. So in this topic, or in this subtopic, we are now looking at different compounding periods. This is where now we are saying the interest is compounded monthly, semi-annually, daily, and quarterly or biannually. Okay, so for your prior knowledge, what you should be knowing by now, you should be knowing what is an investment, which is the money saved with financial institutions like banks to earn interest. You should be knowing what is hire purchase agreement and which formula do we normally use to calculate the hire purchase agreement. So your hire purchase agreement, we are talking about the short-term loans, whereby we use the interest is calculated using the simple interest. So simple and compound interest formula, you already know that it is calculated using A, it's equals to P into 1 plus I times N, and A, it's equals to P into 1 plus I to the exponent N. And you should be knowing by now that N, it stands for the time period for the investment. And you must be knowing the percentages as well, or you must be knowing how to convert a number from a number to a percentage and from a percentage to a number. Okay, so the effects of different compounding periods. In most real world applications, interest is compounded more often than once a year. When this is the case, you have to adjust the formulas and use an interest rate and a value for N which matches the compounding period. In other words, if compounding is performed monthly, the interest rate must be divided by 12 to obtain a monthly interest rate, and N must be in months as well. Let's look at the different compounding periods. For example, let's say they're saying whatever that you have invested, it's compounded monthly. So you have to ask yourself, how many months do you have in a year? So this is where now you divide your interest by 12 and you multiply your N by the 12. So when we are talking about quarterly, you ask yourself, how many quarters do you have in a year? Which is going to be 4, right? So you divide your interest rate by the 4 and then you multiply the N by the 4. Then when it's semi-annually or biannually, you divide it by 2, because now we are talking about the half in a year. So that is 6 months and another 6 months, which is 2. And then daily, we are going to say it's 365, since you have 365 days in a year. Okay, so let's look at example number 1. Please make sure that you have a pencil, you have a pen, and your calculator, so that as I'm doing all of this, you are also doing it as well. So let's look at example number 1. It says, determine the value 100 Rand will grow to in 5 years if interest is calculated at 12% per annum, compounded A, monthly, B, quarterly, C, semi-annually, and D, daily. Okay, so it's A, it's equals to P into 1 plus I to the exponent N. You know the formula that you are supposed to use, right? Because they're saying your interest is compounded. It's compounded. So you have to say it's A, it's equals to P into 1 plus I to the exponent N. Don't forget your N, it's your A, it stands for the final amount. Your P, it's the principal amount. Then your I, this is the interest rate. And then the N, it's the number of years, or the number of your interest, number of periods, sorry. Okay, so let's substitute our A. What are we given? So we are given the principal amount, or the amount that is invested, which is going to be your P, right? So your P, you are given that it is 100 rands, and then it is going to grow for a period of 5 years, so your N is going to be 5 years. Then if interest is calculated at 12%, so it means your I, which is the interest rate, it is going to be given as 12%. Don't forget, always your percentage, you need to convert it to a number by dividing by 100, then you'll get your 0.12. So it means here, since we are calculating the final amount, or the amount that is accumulated after 5 years, we are calculating our A, right? Okay, so now we are going to say it's A, it's equals to your P, it is 100 rands, so it's 1 plus. So where there is I, you are going to substitute your 0.12, right, which is your interest rate. But now the different from, so now when you are looking at letter A, they're saying compounded monthly. So now it means your interest will be paid monthly. So you need to divide the interest by the 12 because you have got 12 months in a year, right? Okay, and then for your N, it is going to be 5 times the 12. So you also multiply your N by the 12 so that you get the number of months. So you are going to have your 100 rands, 1 plus the 0.12 divided by that. Then your 5 times the 12, it is going to give you 60. So just substitute all of that in a calculator for me. Okay, so it is going to be 181.67 cents. So it means if our interest is compounded monthly, the amount that you are going to have at the end of 5 years, it is going to be 181.67 cents. Let's move to the second one. The second one, it's going to be quarterly. So it's going to be A, it's equals to P into 1 plus I times N. So what are we given? We are given that our P, which is the principal amount, it is given as 100 rands. Your I, it is given as 0.12. But remember, I said you need to divide the I by the compounding period. So in this case, since we are looking at letter B, which is quarterly, you will say it's going to be, you're going to divide by 4. So your N, it is going to be the number of years, which is 5. Then you multiply it by the 4, which is the quarterly, the compounding period. So you will have A, it is equals to your P, it is 100 rands. Then it's 1 plus your I. You substitute this whole thing as it is. It's going to be 0.12 divided by 4. Okay, it's compounded. We're making a mistake here. Let's erase there. It's compounded, so you need to use the formula of compound interest. So your N, it is going to be the 5 times the 4, right? So your A will be equals to 100 rands. It's 1 plus 0.12 divided by 4. Then the exponent, it is going to be 20. So your A, it is equals to 100 into 1 plus 0.12. You divide by the 4, which is quarterly. So it means your interest will be received 4 times in a year, right? So your final amount, it is going to be 180 rands, 611 cents. Okay, let's move to the second one. The second one, it's the one of the semi-annually. So semi-annually, it's going to be divided by 2, right? So it means you'll say it's A, it's equals to P into 1 plus I to the exponent N. Okay, what are we given? We are given that your P, it is 100 rands. Your I, it is given as 0, 0,12. Then since it's semi-annually, you've got you've got 2 6 months in a year. Sorry, you've got 2 6 months in a year, so it's going to be 2. Then your n, it is going to be the 2 times the 5, because you want to find out how many halves do you have in 5 years, right? Okay, so it's going to be A, it's equals to your P, it is going to be 100 rands. It's 1 plus your I will be 0, 0,12 divided by 2. Okay, and then the exponent, it is going to be 2 times 5. So it's A, it's equals to 100 rands into 1 plus 0, 0,12 divided by 2. It's 2 times 5, then you will get the 10. Then if you put all of this in a calculator, you will get 1 plus 0, 0,12. So you will get 179,085 cents. Okay, and then the last one, it's the one of daily. How many days do you have in a year? It's going to be 365. So it means you will say, this is C, let's do D. So it is going to be A, it's equals to P into 1 plus I to the exponent n. Your principal amount is still the same amount, so it's going to be the 100 rands. It's 1 plus your I, it is still 0, 0,12. Then you divide the interest by 365 days. You close, and then the exponent, it is going to be 365 times the 5. So it's going to be 100 into 1 plus 0, 0,12 all over 365. So you close the brackets, and then the exponent will be 365 times the 5. You will get 182,194. So you'll get 182 rands, 194 cents. So always when the compounding period has changed to be monthly, you divide by 12, you divide your interest by 12, and then you multiply your n by the 12. If it's semi-annually, then you'll divide your interest by 2, then you multiply your n by 2. If it's daily, you say it's 3, you divide by 365, and then you multiply the n by 365. Okay, so quickly do this one for me. Example number 2. It says Rose invested 7,000 into a savings account for 4 years. If the saving account offers an interest rate of 7% per annum compounded monthly, determine how much she will have after 4 years. I am giving you exactly 2 minutes. Make sure you list all what you have given first, and then you substitute nicely into your equations. Your 2 minutes starts now. Okay, your time is up. Okay, let's go through example number 2. So Rose invested 7,000 into a savings account. So the amount that is invested here, it is how much? It is 7,000. So this is the initial amount, or it's our principal amount, or the amount that is invested, right? So it means when we are listing down what we are given, we'll say our A, our P, our I, then our N, right? So your P, of which is the principal amount, it is going to be given as 7,000. Okay, and then they're saying the 7,000, it's invested into a savings account for a period of 4 years. So it means your N, it is going to be 4 years. Okay, if the savings account offers an interest rate of 7% per annum compounded monthly, so it means your interest rate, it is going to be given as 7%, right? Remember, you don't just put it as, you don't substitute it as 7%. So you say 7% divided by the 100, you'll get 0,07. Always make sure that you divide by the 100. Okay, per annum compounded monthly. So the minute they say compounded monthly, you need to ask yourself, how many months do you have in a year, right? Okay, so it means now your interest rate is going to be divided by the 12, and also your 4, it is going to be multiplied by that 12. Ne? So they're saying now you must determine how much she will have after 4 years. So the amount that is accumulated, which is our A, or the final amount is the amount that we are finding right now. So you'll say it's A, it's equals to P into 1 plus I to the exponent N. How did I know that I'm supposed to use the formula of compound interest instead of the simple interest? They said compounded monthly. Ne? So you say it's A, it's equals to the P, it is going to be given as 7,000. It's 1 plus your I, it is given as 0,07. But now the compounding periods have changed to be monthly. So it means your interest will be received each and every month. So you need to divide by 12. And then the exponent, it is going to be 12 times the number of years, which is 4. Right? So your A will be equals to the 7,000. 1 plus 0,07 all over 12 to the exponent, you say 12 times the 4, then you'll get the 48. So your A will be equals to, please punch everything in your calculator. You will press the 7,000 and then you will open a bracket, and then inside the bracket you'll insert 1, then you say plus, then you enter that those two blocks with fractions, ne? Then you substitute 0,07, then you go down and you substitute the 12, then you close the bracket, then for the exponent you'll substitute the 48. So your answer, it is going to be 9,254,38 cents. You see? It's very easy. Then you'll get your mark for the correct substitution into the correct formula. You'll also get a mark for the formula, for the answer, but there is also a mark for knowing that you have to multiply by that 4, and also for dividing the interest by this. So you have easy marks. Ne? If you have a question, you want to find out maybe where how I got the answer, maybe you got confused somewhere, please don't be afraid to post the question on the chat. Ne? Okay, let's move to the types of depreciation. This is just a revision from the previous lesson. As an asset gets used over time, it loses its value, and the rate at which it loses its value, we call it depreciation. So we have two types of depreciation, which is the straight line depreciation, and we've got the reducing balance depreciation. So the straight line depreciation may be used when an asset is worth nothing at the end of the depreciation period. The asset depreciates at a constant amount. Usually the asset is donated to charities. So the formula that we use for the straight line depreciation, it is going to be your A, it's equals to P into 1 minus the interest rate times the N, and you close the bracket. And then the formula that we use for the reducing balance depreciation, it is going to be A, it is equals to P into 1 minus I to the exponent N. In an exam, you don't have to guess which formula you need to use, because they do give you a hint in your statement. So if they say using the reducing balance method, you need to use this formula. And if they say using the straight line method, you use that formula. You need to know how to use both equations. Okay, let's quickly move to example number 3. Please do it for me for 2 minutes as well. Let me read it out for you. It's Tandi's car, which was bought 5 years ago, is now worth 80,434 rands, 88 cents. What was the original purchase of the car if it's depreciated at 8% per annum, compounded daily? The compounding period, don't forget. So I'm giving you exactly 2 minutes. Okay, your 2 minutes is up. Let's go through the question. It says Tandi's car, which was bought 5 years ago, is now worth 80,434.88 cents. So what are we given? So you must have your A, your P, your I, and your N. So Tandi's car, which was bought 5 years ago, is now worth 80,434.88. So 80,434.88 cents is the final amount. Are we together? Because this car was bought when? 5 years ago. Ne? So it means your A, which is the final amount, will be 80,434.88, which is your book value. 5 years ago, that's your N. What was the original purchase of the car if it depreciated at 8% per annum compounded daily? Ne? So your P is the one that we are looking for, because now we want to find out how much this car was costed 5 years ago, right? Okay, and then the 8%, your I, it is going to be given as 8%. You divide it by 100 so that you can take it to a number, then you'll get 0,08, right? And then for the fact that they said it's compounded daily, it means now the compounding period has changed. For your number of years, you are going to multiply it by 365, and for your interest, you are going to divide it by 365. Are we together? Okay, so it means you'll say A, it is equals to P into 1 plus I to the exponent N. Okay, so your A, it is given as 80,434.88. Don't forget to put the R. We are talking about money. It's equals to P. P is the one that we are looking for. Okay, so it's 1 plus your I. It is given as 0,08. Ne? You divide it by 365. Why are we dividing by 365? It's because of that compounded daily. Okay, so the exponent, it is going to be given as the 5 times the 365. Are we together? So how are we going to solve for this P? So we need to divide by everything that we are not looking for. Ne? So in this case, because I want to find P, I will divide by 1 plus 0,08, 365 to the exponent 5 times 365. On the other side, it's 1 plus 0,08 all over 365 to the exponent 5 times 365. So the whole of this, if you divide it by this, you'll get a 1. Then your P, it is going to be equals to, I got 53,991. Let me just double check. So it is going to be 80,434.88 divided by 1 plus 0,08 all over 365. To the exponent 5 times 365. Okay, so that's 53,919.48 cents. Ne? So that's your answer. So we have listed everything that we were given, which is the A, we were given the I, and we were given them N, and then they said we must find our P. So you will get full marks for the correct substitution into the correct formula, right? And you also get a mark for knowing that this, you need to divide it by the 365, and you also need to multiply that side by the 365. Then you also get a mark for the final answer. Are we together, guys? Okay, there's a question on the chart. It says, do I always have to round the answer to 2 decimals or in full? Okay, I don't understand the part of in full, but when we are dealing with finance, you don't round off until you can get to the final answer, ne? So round off when you have gotten to the final answer, then you round off to 2 decimal places. But normally the question will specify if you must round off to 2 decimal places or what. But if it's not specified, round off to 2 decimal places. You only round off at the end, ne? Because if you start rounding off on top, or when you have started with your question, your answer at the end, it's gonna be incorrect. Oh, thank you for that. Thank you, guys. Okay, so we've made a mistake. Tandi's car, which was bought 5 years ago. Now we are talking about depreciation. I'm so sorry for that. I made a huge mistake. Okay, so since we are talking about depreciation, now in the formula we need to put the negative. In our formula, we need to put the negative, not the plus, because we are talking about the depreciation. Thank you very much. Okay, so we need to put the negative there. And also, we need to substitute with a negative. I'll just substitute the negative only. Then we can just change our answer because it's only the negative. Now it makes sense why the P is smaller than the A. Okay, so you've got your negative, and then you've got your negative. Don't forget depreciation. Thank you very much, guys. Depreciation, you need to put the negative. So in your formula, you use the equation of 1 minus I. Not 1 plus the I, because we are talking about the depreciation. Okay, so let's just fix that. Let's fix our answer. So it is going to be the 80,340, 434,88. So that is going to be, your P will be 120,000, 00. So it's just 120,000. Now it makes perfect sense, because the car was bought 5 years ago. So 5 years ago, it should have costed more than what is costing now, because it has lost the value. The 80,434.88 cents, it's the book value of the car after the 5 years. Right? Thank you very much, guys. I'm really happy that you are asking questions and you are correcting me. It means you are also involved in this lesson. Okay, keep the questions coming. I like the energy that you are coming with. Let's move to example number 4. Let me see. Yeah, it's the last example before we move to the timelines. Okay, so example number 4, it says an investment grows from 6,700 to 8,510.59 cents in 3 years. Determine the interest rate received if interest was compounded monthly. So the interest is compounded monthly. The investment, it grows from 6,700 to 8,510 in 3 years. I am giving you exactly 2 minutes to do this one. So let's go through our question. It says an investment grows from 6,700 to 8,510.59 cents in 3 years. So now we are talking about the money that has been invested, right? We are not talking about depreciation. Hence, the formula that we are going to use, it is going to be your A, it is equals to P into 1 plus I to the exponent. And why are we using the one of a compound, simple compound interest? It is because of that compounded. So don't make a mistake and you use the formula of the simple interest. Okay, so what are we given? Let's write down everything that we have been given. And if an investment grows from 6,700 to 8,510, it means our final amount, or the accumulated amount, it is going to be how much? Your 8,510.59 cent. And then your P, which is the amount that has been invested, or your principal amount, it is going to be the 6,700. Then the interest rate, we are not given, it's the one that we are looking for. And then your N, which is the number of years, it is going to be the 3 years. Okay, so if they say determine the interest rate received if the interest was compounded monthly, don't forget the compounding period. You need to multiply your number of years by the 12, because you have got 12 months in a year, right? Okay, so let's substitute all our values. You've got your A, it is given as 8,510.59 cent. And then your P, it is given as your 6,700. You open your bracket, you substitute your 1, you have plus, then your simple interest, the one that we are looking for. Sorry, your interest, it is going to be your I, you close the brackets, then the exponent, it is going to be 3 times the 12. Don't forget, when we have the different compounding period, now the compounding period, it's monthly. So it means your I needs to be divided by 12 as well. Ne? Okay, so from here, we need to solve for our I. So how are we going to solve for the I? First things first, we need to get rid of everything that we are not looking for, right? So you've got your 8,510.59, it's equals to the 6,700, it's 1 plus the I all over 12 to the exponent, the one is going to be 36. Okay, so first things first, I am going to divide by the 6,700. I need to get rid of the P, ne? So 6,700 divided by 6,700, I am going to get a 1, right? Okay, let's substitute, let's put everything in our calculator. I'll have to erase this side. Okay, so let's substitute to the other side, which is the 8,510.59 cent. You divide it by the 6,700, right? So you'll get 1,270237313. Don't forget, you don't round off before you can get to the final answer, ne? Because that will make your answer to be incorrect. So I still have, it is equals to the 1 plus the I all over the 12 to the exponent 36. So my exponent, it is 36, okay? So I need to get rid of that exponent. How do you get rid of the exponent? You need to put the root of the 36 and also put the root of the 36, right? Okay, so you will have, okay, let me check if I still have space. Okay, we don't have space. Let me just use a different color, ne? So that you don't get confused. Okay, so the 6th root of the 36th root of all of that, it is going to give me 1,0066666672. It is equals to, now I'm left with 1 plus I all over the 12. Ne? So the 1, I can take it to the other side, right? So it means I can have the 1,0066666672 minus 1, it is equals to I all over the 12. How do I get rid of that 12? How do I get rid of this 12? You can multiply both sides by 12 all over 1, or you can just multiply this side by 12 and also multiply this side by 12. So the 12 and the 12, it is going to go out. Okay, so from there I can say the answer minus 1, I get all of that, and then I multiply it by 12. My I will be 0,08. Don't forget your answer is it needs to be in percentage. So it means you still need to multiply that I by the 100 so that your I could be the 8%. Okay, so my answer was 8%. Let me just explain all my steps nicely. So you substituted your A, substituted the P, then substituted your I, or the I that we are looking for, you put it as an unknown. You divide it by 12 because it's compounded monthly. Then the N, it is going to be the number of years, which is 3. Then you multiply it by the 12, right? Okay, so you get the full marks for the correct substitution, ne? And then the number of years, the way you substituted there, you'll also get a mark. And for dividing by that 12, you'll also get a mark. Then you have to get rid of your P. So you divide by 6,700 on both sides. And then on the other side, then you have to put the root of the 36, ne? So that you can get rid of the 36. You can't take the 1 from the bracket to the other side of the equal sign before you can get rid of that 36, ne? So how do you get rid of the 36? You introduce the root of 36 and the root of 36. It's either you do that, or you can say you multiply the exponent by 1 all over 36, which is the inverse of that. You just need to remember your algebra from first term, guys. It's very easy. When you have something like this, when you have x to the exponent 36, it is equals to 6. I'm just making an example. How do you get rid of that exponent 36? You'll either say times, because this is 36 all over 1, you'll either say 1 all over 36, and on the other side you also do the same thing, because remember what you have done on the right, you also do it on the left, né? So it means the exponent there, because you have 1, you can say times the 1 all over the 36. So it's either you do that, or you just introduced the root of 36. So you just say root 36, and even on the other side you just say it's root 36, ne? So this is simply algebra. When you are simplifying, you're just doing your algebra that you have done first term. Then you'll get your full marks when you have gotten the answer of 8%. If you have a question, please don't be afraid to ask, ne? Okay, let's quickly move to the timelines. It is a useful tool to use the timelines where there is a change to an interest rate, the change in the period, as well as problems where there are additional withdrawals and or deposits. So in your questions or in your problems, when you're solving problems, if you discover that there are additional withdrawals or additional deposits, you need to use the timelines, ne? It makes it very easy to use the timelines. So the timeline is used to represent the data from the information given. It is useful and helpful to represent the data on the timeline even when there is no change in any interest or time period. Okay, let's look at the first example whereby there's a change in the interest rate. So I will do example 5, then you will do the second example, ne? Okay, so example 5, Thabiso invests 3,000 into a savings account at an interest rate of 5.5% per annum, compounded monthly. There's that word again, compounded monthly, ne? Don't forget. So after 3 years, the interest rate, it drops to 3.25% per annum, compounded monthly again, right? Okay, so how much will he have after 5 years? So how do you do your timeline? This is your timeline. You have your T0, T1, T2, T3, T4, T5. So I've got year 1, year 2, year 3, year 4, and the year 5. So they say this person, he invests 3,000. So it means at T0, he will invest how much? The 3,000, ne? Into a savings account at an interest rate of 5.5%. So the 5.5%, we can write it as, okay, let me just write it as it is. then it's compounded monthly. If we compound monthly, we divide by the 12, right? Okay, so after 3 years, the interest rate drops. So it means immediately after 3 years, the interest, it drops or it changes. So the 5.5%, it's going to be the interest for year 1, year 2, and the year 3. So at year 3, the interest, it changes, right? So now the new interest rate, it is going to be the 3.25%, right? Also, it is compounded monthly, so it means your interest, it is going to be divided by 12 because it is compounded monthly. So how much will he have after 5 years? So with the interest rate, you'll say it is A, it's equals to P into 1 plus I to the exponent N, right? So your A, we are looking for the IA of which is the accumulated amount. Your P, it's the amount that is invested. How much is invested in this case? It is 3,000, right? So it's 1 plus your I, we said it is 5.5%, right? Remember, 5.5, you can't just substitute it as it is. You need to say 5.5 divided by the 100. Then you will get 0.055. And then since it's compounded monthly, you need to divide it by the 12. You close the bracket. This interest is going to be effective for how long? It is going to be for 3 years, right? Because you'll say it's year 1, it's year 2, and it's year 3. So it means you will have the 3 times the 12, since we said it is compounded monthly. Okay, so what happens with the new interest rate? When the interest rate has dropped, what happens? So you're still going to receive the interest, but now the interest is going to be for how long? It is going to be for 2 years. So it's going to be the year 4 and the year 5, right? And then the interest rate, it is going to be 3.25. So in such a case whereby the interest rate changes, you are going to multiply by the new interest rate. So it's going to be 1 plus your I, it is 3.25. Don't forget, you can't just substitute it as it is. It's 3.25%, so you need to convert it to a number. So you'll say 3.25, you divide it by 100, then you get 0.0325. Ne? So it is going to be 0.0325. You divide it by the 12 because we said it was compounded monthly, right? Let me erase. So the exponent there, it is going to be the 12 times. This interest will be, it's going to be effective for how long? So it's going to be 1, 2, it's only 2 years. Ne? So you only put the 2 years. Then you just write, you put everything as it is in your calculator, ne? To avoid having to round off. So just put everything in your calculator, because you'll end up making mistakes. So it's 3,000. You open a bracket, it's 1 plus 0.055, the division line, which is 12. You close the bracket, then the exponent will be the 3 times the 12. Then you open another bracket, you substitute 1 plus 0.0325. You divide by the 12. You close the brackets, then the exponent there, you make it to be 12 times the 2. Then your answer, it is going to be 3,774.05 cents. So the amount that this person is going to have after 3 years, it is going to be 3,774.05 cents. So the only interest that he received, it was 774.05 cents. Then you get your full marks for correct substitution into the correct formula, for multiplying with the new interest rate, and also for the correct answer. Are we together? Okay, so the second one, you are the one who's going to do it. Please do example 6. It says, in 1 year, an investment grows to an amount of 3,606.02 cents. For the first 6 months, the interest rate is 9% compounded monthly. There's that magic word again. After this, the interest rate changes to 12% per annum, compounded quarterly. Okay, so how much was initially invested? Okay, I am giving you another 2 minutes. Please quickly do this one for me. Okay, your time is up. Okay, so let's do this one. It says, in 1 year, an investment grows to an amount of 3,606.02 cents. So that's your A, right? Because it's your accumulated amount. Ne? For the first 6 months, the interest rate is 9% compounded monthly. So let me just do my timeline. Okay, so now I'm gonna write it in terms of the months, because I'm given my information in months. So I'll have T0, T1, T2, T3, T4, T5, T6, T7, T8, T9, T10, T11, and T12. Why is it 12? Because I've got 12 months in a year, right? Okay, so an investment grows to an amount of 3,606. So it means for my A, or at T12, I will have the 3,606.02. Okay, and then for the first 6 months, the interest rate is 9%. So this is month 1, 2, 3, 4, 5, 6. At T6, I'll have an interest rate of 9% per annum, and it's compounded monthly. So it means we divide it by the 12. Ne? So after this, the interest rate changes to 12%. So it means from T6 up until T12, the interest rate is no longer the 9%, but it now is 12%. Ne? And it is compounded quarterly. So if it's compounded quarterly, how many quarters do you have in a year? It is going to be 4. So it means we are going to divide it by the 4. So how much was initially invested? So it means we are calculating what? We are calculating our P, of which is our principal amount, right? So you'll write your formula. It's A, it's equals to P into 1 plus I to the exponent N. Already you know that from the previous example that if there's a change in an interest rate, then you are going to multiply the interest, isn't it? Or the interest. So it means here, since the interest has changed twice, I'll have another interest, which is multiplying this one, another bracket with 1 plus the I to the exponent N. Ne? So your A, it is going to be the 3,606.02. It is equals to P. You open a bracket, it's 1 plus the I, the first I, it is going to be the 0,09. Do not forget, you don't substitute 9% as it is, but you need to convert it to a number. So you need to say 9% divided by the 100, then you will get 0,09. And since it's compounded monthly, then you need to divide by 12. You close the bracket. Then where there is N, you will have the 6. What is the 6 for? They said for the first 6 months, the interest rate is 9%. Why am I not multiplying 6 by 12? Because it is already in months. They said it's compounded monthly, right? And we are given the 6 months. They are not in years. When we multiply by 12, it's when we are converting years to months. But now it is already 6 months. So we just put the 6 as it is. I hope I'm making myself clear. Ne? Okay, so let's continue. So you open a bracket. It is going to be 1 plus your I, the new I for the remaining 6 months, it is going to be 12%. Again, you don't substitute 12% as it is. You divide by the 100. Ne? So it means you'll have 0.12 all over. Quarterly, you have 4. So you'll divide by 4 there because it's compounded quarterly. Then the exponent, here's the interesting part. So from the 6 months going to the 12th month, it means you have how many months there? You've got 6 months, right? And how many quarters do you have in a year? You've got 4 quarters. Ne? So already this is half the quarter. I don't know if I'm making sense. So the 6 months, it is already 1 all over 2. It's half of the quarter. So you will say 1 over 2 times the 4. Ne? So 6 months, it's half of the year. So you say half times the 4. Ne? Okay, so from there, I will have the 3606.02. We are solving for P. So if I am solving for P, it's very easy. I just divide by everything that I'm not looking for, and I am left with what I'm looking for because this P is multiplying that bracket. Ne? So it means I'll have equals to P into 1 plus 0.09, all over 12 to the exponent 6 into 1 plus 0.12 all over 4 to the exponent. If I multiply the half by the 4, I'll get a 2. So I divide by everything that I'm not looking for, which is going to be 1 plus 0.09 divided by 12 to the exponent 6. Then it's 1 plus 0.12 divided by 4 to the exponent 2. Let me see if I still have space this side. Okay. So the same thing that I've done this side, I also do it on the other side, right? So it means I'll also have 1 plus 0.09 divided by 12 to the exponent 6. Again, it's going to be 1 plus 0.12 all over 4 to the exponent 2. So here, let me use a different color. So all of this will divide this, and then I'll be left with 1. So my P will be given as, let's substitute everything as it is. Don't substitute one by one. Just substitute everything as it is so that you don't make mistakes along the way. Ne? So how are you going to substitute all of that? You'll press those 2 blocks like that in your Casio. So it's going to be like that. Then you substitute your 3,606.02 cents. It's all over. You open a bracket, you substitute 1 plus 0.09. It's all over the 12. You close the brackets. Then as an exponent, you'll substitute the 6. You open a bracket, it's 1 plus the 0.12. It's all over the 4. You close the brackets to the exponent 2. Then your answer will be given as 3,249.99 cents. So I am getting 3,249.99 cents. I hope you also got the same answer. Okay, so you get full marks for correct substitution into the correct formula. You also get correct marks for rounding, for converting your percentage to a number and then dividing by 12. Also this side, and for your N, and also for your N, and you'll also get a mark for that final answer. Are we together? Okay. So now let's look at additional withdrawals or deposit. So this one is easy and straightforward. When we are talking about additional withdrawals, when it's when you are withdrawing, you are taking out money, right? So you just subtract that particular money with its interest. When you are depositing, you are putting money in the bank, right? So if you are putting in money, you say plus the particular money that you are depositing with its interest. Are we together? Okay, so let's look at example 7. It says 20,000 is deposited into an account which offers an interest rate of 9% per annum compounded monthly. Okay, so 20,000 is deposited into an account which offers an interest rate of 9%. So this is your I, then this is your deposit or your initial P. Ne? Compounded monthly. Don't forget, when it's compounded monthly, what you need to do. 2 years later, 5,000 is withdrawn from the account. Ne? How much will be in the account after 8 years? So let's do our timeline. Okay, so my timeline is going to be in years. So it's going to be T0, year 1, year 2, year 3, year 4, year 5, year 6, year 7, and year 8, which is the final year, right? So they're saying how much is deposited initially? It is 20,000. So 20,000, it is deposited. Ne? And then what happens? Which offers an interest rate of 9% per annum. So the interest rate here, it is 9%. Since it's compounded monthly, we divide the interest by the 100. Sorry. We divide the 0.09 by the 12 since it's monthly. Okay. So now they're saying 2 years later, 5,000 is withdrawn. So now 5,000 is taken out from the account, right? So you've got the first year and the second year. So year 2, we subtract how much? We subtract the 5,000 because the 5,000 is withdrawn, right? Okay, so how much will be in the account after 8 years? So we want to find out how much money is going to be accumulated after 8 years. Ne? So first things first, we will calculate the 20,000 and its interest, or the interest that is going to be accumulated within this 8 years. Ne? I don't know if I'm making sense. So first things first, you say it's A, it's equals to P into 1 plus I to the exponent N. So your A will be equals to the P. It is given as the 20,000. Then it's 1 plus the I. We said it is going to be 0.09. But since it is compounded monthly, then it means we need to divide the interest by 12. Okay? Then the exponent is going to be the 12 times. Okay? So we are finding the interest that this 20,000 is going to accumulate over the period of 8 years. So we need to find how many months do we have in 8 years. So it's going to be the 12 times the 8. Ne? So you'll have 20,000 into 1 plus 0.09 all over the 12. You close the bracket. Then the exponent is 12 times the 8. So it means you will have how much? 40,978,42456. Do not forget, you can't round off before you can get to the final answer. Ne? Okay, so 20,000 is going to accumulate that interest. Ne? We are not done. We still have information in our statement. Okay, so after 2 years, what happens? This person withdraws the 5,000. Ne? So this 5,000 was going to accumulate a certain interest over the remaining period. Ne? The 5,000 was still going to accumulate the interest, right? So if I take out the 5,000 after T2, then it means I need to take out the interest that was going to be accumulated over the remaining period as well. I hope I am making sense. So it means I still have to say in my formula minus the P, which is withdrawn, and the interest rate, which is, let me use a different pen. So it means I still need to say minus the P and also the interest that the P was going to accumulate. Ne? So it's 1 plus the I to the exponent n. Right? So it means here I'll have minus the P is 5,000, of which it's the amount that was withdrawn. So it's 5,000 into 1 plus the I, it is going to be 0.09, it isn't changed, all over 12 because it's still monthly. Then the exponent, it is going to be the 12. But how many months do you have in the remaining year? Or this 5,000 was going to accumulate an interest for how many years? So it is going to start calculating from T2. So you're starting to calculate from year 2. It's year 1, 2, 3, 4, 5, 6. So it means this 5,000 was going to accumulate an interest for the remaining 1, 2, 3, 4, 5, 6. So you need to say 12 times the 6. Are we together? Okay, so we need to subtract the 5,000 and its interest. So it's going to be 1 plus 0.09 all over the 12. Close bracket. The exponent, it is going to be 12 times 6. So it is going to be 8,562,763534. Ne? So you say, you subtract the 2, 40,978,426 minus 8,567,763534. So you will have 32,410,66. So at the end of T8 or year 8, you are going to have 32,410,66 cents. So whenever there is a withdrawal, you subtract, and then whenever there is a deposit, you add, and you also add the interest that is going to be accumulated. Are we together? So with that statement, you didn't even have to do this separately, but you could have just said, okay, so it's A, it's equals to P into 1 plus the I to the exponent n. Since there is one withdrawal, you say subtract the withdrawal with the interest. So this is the formula. But if there's an additional withdrawal, then instead of that minus, it is going to be the plus. And if there's a change in the interest rates, then you multiply the both interest rates. I hope this explanation was clear. Ne? Okay, let's quickly move to nominal and effective interest rate. We are almost out of time. So the nominal interest rate is the rate that is quoted in the question. The effective interest rate is the equivalent annual interest rate that you would receive once compounding has been taken into account. In order to compare interest rate with different compounding periods, it is often useful to convert a nominal interest rate into effective rate. Always when you are doing the calculations of nominal and effective interest rate, how do you see the other one is nominal and the other one is effective? So the effective is always much higher than the nominal interest rate. Ne? Let's go to the first question. Okay, so the equation that we use for nominal to effective, if you are converting from nominal to effective, which equation do we use? We use that equation of 1 plus I effective to the exponent 1. It is equals to 1 plus I norm all over m, whereby your m, it stands for the number of times a year the nominal interest rate is compounded. Okay, and your I effective is just effective interest rate. Your I norm, it's nominal interest rate. Ne? Okay, so let's look at example number 9. It says convert an interest rate of 15% per annum compounded monthly to an effective interest rate. So obviously you have 1 plus I effective to the exponent 1. It is equals to 1 plus I norm divided by m to the exponent m. So 1 plus I effective, we are converting to an effective interest rate. So we are moving from norm to effective. So it's going to be equals to 1 plus I norm. It is going to be 15%, but obviously I can't substitute 15% as it is. So I divide it by 100. So you'll say 15 divided by 100, you'll get 0.12. So it's going to be 0.12. You divide by monthly. How many months do you have in a year? It is going to be 12. Then the exponent this side, it is going to be 12 as well, right? Because it's still your months. So I effective, it is equals to 1 plus 0.12 divided by 12. We need to solve for the I effective. So what do? You take this one, you take it to the other side. And remember, when you take it to the other side, it changes the sign from positive to be -1. So your I effective, it is going to be 1 plus 0.12 divided by 12. You close the bracket, exponent is 12, then it's -1. So you'll get 0.127. Let's just say 127. Okay, so if you multiply this by 100, because obviously you need to take it to percentage, your I effective, it is going to be, you will have 12.668%. So as you can see, okay, so your I effective, you'll have that 0.127, you multiply it by 100, then you'll get the 12.68%. 68%, I'm sorry for that. And then let's quickly move to example 10. I'll let you do this one. I've been doing the talking all alone. So quickly do example 10. It says convert an interest rate of 8.25% per annum compounded quarterly to an effective interest rate. Quickly do that one for me. Please don't forget the compounding periods. Ne? The minute they said it's compounded quarterly, compounded monthly, what is it that you need to do? I'm giving you 2 minutes. Okay, your time is up. Okay, so it is going to be 1 plus I effective. It's equals to your 1 plus I norm all over m to the exponent m. So it's 1 plus I effective. It is equals to 1 plus, we are converting to an effective interest rate, right? So your I norm, it is going to be the 8.25. But remember, you need to divide it by 100. So if you divide it by 100, you'll get 0.0825. Then you divide it by quarterly. How many quarters do you have in a year? It's 4. Then the exponent there is going to be 4 as well. So you will have 1 plus I effective. It is equals to 1 plus 0.0825 all over 4. The exponent will be 4. If I take this to the other side, it is going to be -1. Ne? Let me just erase it this side. So I effective would be, it's 1 plus 0.0825 divided by 4. Then your answer would be 0.085. Ne? Then you multiply it by 100 and you will get that I effective will be equals to 8.5 0.51%. Then you get your full marks. Ne? Okay, so in summary, when there is additional withdrawals, additional deposits, or change in the interest rate, you must always draw a timeline so that you make things easy for yourself. Ne? When there is change in the interest rate, multiply the brackets together. Okay, and then number 3, when we dealing with deposits or withdrawals, N is always the amount of time left in the account from the time that the deposit or withdrawal is made, not the time it has been in the account. So when there is change in the interest rate, you know, multiply the brackets, and if there is additional deposits, you add also with the interest. When there is additional withdrawals, you subtract also with the interest. And there is a question, 15 divided by 100, it is equals to 0.15. I don't know it's for which question. Let me just go back to what I have written. Oh, example number 9. Convert an interest rate of 15% per annum compounded monthly to an effective interest rate. I'm so sorry, guys. 15 divided by 100, it is 15 divided by the 100, it is going to be 0.15. It is going to be 0.15. So instead of the 0.12, we put 0.15, and we also put the 0.15 that side. I'm blaming you for the mistakes that I'm making, you know. Because you are quiet, you're not asking questions. It's like I'm talking alone. You are not engaging. So I become tired with talking alone. Okay, so when you say the 15% divided by 100, you get 0.15, ne? And then the I norm will be 0.15. Thank you for that, ne? So it's 0.15 as well. Then if I put everything in the calculator, it is going to be 1 plus 0.15 divided by the 12. You close the brackets, then the exponent is 12 minus 1. So it's going to be 0.1608. Let's multiply it by 100. You will get 16.08%. Thank you for that, ne? So we have come to the end of our lesson. I don't know if there is any question. Please, if there is any question, do post on the chat and I will be able to respond, ne? So I've created the worksheet 1. You make sure that you do it at home. I created worksheet number 1 and worksheet number 2. So make sure that you do it at home, and then if you have any questions, you go to your teachers. They'll be able to help you, ne? Okay, so number 1, it says Kumbuzo deposits 30,000 in a bank account and leaves the money in the account for 4 years. Okay, so for the first 2 years, interest is calculated at 4.3% compounded quarterly. For the remaining 2 years, interest is calculated at 5% per annum compounded monthly. How much money will be in the account at the end of the 4 years? So obviously this question, it needs you to draw a timeline, ne? So there is a change in the interest rate. So the brackets, that will multiply them. Number 2, Tariq borrows 10,000 for 2 years. For the first 6 months, interest is calculated at 20% per annum compounded monthly. Thereafter, interest is calculated 22% per annum compounded monthly. How much does Tariq owe after 2 years? Okay, and then that one also, it's the change in the interest rate. So 3, Johannes opened a savings account 20 years ago. On opening the account, he immediately deposited 4,000. he added a further 10,000. So now there's an additional deposit, ne? A further 10,000 10 years ago. 5 years ago, he withdrew 5,000 to contribute towards his uncle's funeral. So he withdrew 5,000 rands. So it means now there's an additional withdrawal. Okay, so the effective annual interest rate on the account is 7.2% per annum. How much money is in the account today? Okay, so it's everything that we have done. Worksheet number 2, number 1, Harry takes out a loan and the bank quotes him an interest rate of 20% per annum compounded monthly. Calculate the effective interest rate that he will pay. Okay, so that one, simple and straightforward. You know the formula that you need to use. Number 2, if a bank offers an interest rate of 10.2% per annum compounded monthly, determine the effective interest rate, correct 1 decimal place. Again, you know the formula, you just substitute what you have, and since it's compounded monthly, you know what to do where there is M, right? Okay, number 3, convert an effective interest rate of 8% per annum to nominal rate compounded quarterly. So now it's compounded quarterly and we are moving from effective to nominal. Okay, so number 4, convert a nominal interest rate of 25.5% per annum compounded daily to a nominal rate that is compounded quarterly. And it is then just a typing error. Compounded quarterly. Okay, so when you get home, you will do all of those ones. Make sure that you do them and ask your teachers for assistance. Don't forget your effective interest rate, it needs to be higher than the nominal interest rate. Thank you for joining in today's lesson. See you next time.